Hello everyone, welcome to another video. In my previous videos, I already explained about how to implement neural network models using Python codes and deep learning library TensorFlow and API Keras. So today, in my earlier videos, I showed how to implement codes for how to implement basic neural network model actually using Python and TensorFlow Keras. So I showed the basic neural network model. Today I'll be showing a specific neural network model. I mean how I'll show step-by-step approach of codes, how to write those codes, step-by-step approach for neural networks implementation using Python. Okay, so today I will start with autoencoder for anomaly detection. Now let's write the code directly. For that I have to install first TensorFlow. For this I have to write pip install TensorFlow. Okay, TensorFlow is basically a library, a deep learning library, which is very much useful in the implementation of neural networks. This is TensorFlow. Okay, so this is after that you hit enter plus shift plus enter rather, then it will be installed. So I'm not doing that here since I'm just showing you people. Okay, now after that we have to do some importing of the libraries. So let's do that. For that we have to import the TensorFlow as TF. Import TensorFlow as TF. You can so I'm just abbreviating is at TF since it will be easier for me to write TensorFlow all throughout the code. It's a little longer code actually. Import the TensorFlow actually. Sorry. So do this. Okay. Yeah, so now I will be using TF also the code to designate the TensorFlow library. So that it will be easier for me. I mean, it's a longer word actually. So if I abbreviate it as TF, it will be easier for me. Okay. Well, now let's import other things. Now I'll be importing numpy as np also, since this will be useful for me when I'll be evaluating the model. So our object is actually anomaly detection. So for that I'm actually implementing autoencoder using Python. Okay. Import numpy as np. As np. Okay. Yeah. Then from TensorFlow, Keras to import the word model from TensorFlow dot Keras. Okay. Now, after that, I've already imported model. After that, we have to import the input dense, those things, those layers. So after that I'll be from TensorFlow dot keras dot layers layers input and dense. So why am I importing input and dense here? So as we all know, in case of neural networks, neural networks, the architecture is basically comprising of the input layers, the hidden layers, the output layers. So the input is basically, so we are importing the input keyword. So we import the so that we can design the model. We can, when I'll be forming or creating the intended neural network model, I can use this word, I can use this thing, since this I'll be requiring the input layer, and the dense is basically I'll be inserting the hidden layers by the use of this dense. Okay, so well, that's nice. Now let's go to the next one. Now here scalar. So here we'll be actually importing a min max scalar. This is a very important part. This will be required rather later on in the code. When we'll be normalizing the data. Okay. So for that, I have to import the min max scalar, and for that I have to write like this: scalar preprocessing, import, min max scalar. Okay, so this is the importing part, that we are importing the libraries here in the beginning. So as you can see, this is to have imported TensorFlow, NumPy, the model. We have to create the model of neural network model, then input dense the layers, and this min max scalar for normalizing the data set. Okay, data. So that's fine. Okay, so this is the importing libraries, and this. Now you have to hit the shift plus enter, then to go to the next input, and I'll be writing the next code after this. So for my ease, I'm just erasing this, and I'm just going to write the next code here in this very input line. But you have to understand that those codes will be only static after this point. Okay, yeah. So our next part is basically in this next step, actually more precisely in this code will be to generate the synthetic data. Okay, so generate the synthetic data. This is very important. Why? Because we are going to we're going to be using the these data sets. So that's why it will be very important. Why? You have to just generate the data right now after this, after importing the library. Okay. Now let's generate the data. Yeah. Okay, so let's generate the data. For that, actually generate the synthetic data, or generate synthetic data. I can write like this. So it will be normal data. Actually, when I will be generating the synthetic data, so I mean in this particular cell, we are going to write like normal data. That, and I'll be using the NumPy here. Okay, that's why we have imported the NumPy when we were importing the libraries. So here the normal data underscore data This is numpy that we've already imported, and here will be random.normal 01 1020. So this will be 1020. So that is very important. Since I have started using the NP here, numpy, then we will take the anomalous data. So our idea is actually to detect the anomaly, okay, in the data set. So that's why I have to do get the anomalous data here. Okay, I have to mention I have to actually instruct the computer here with the anomalous data. Dot random dot normal dot random dot normal $100, comma 20. Now the data equals np.bs tag. This tag basically normal data and anomalous data. Okay. np.base tag np.base tag np.base tag np.base tag normal data not normal data and anomalous data. So here we have both incorporated the normal data and anomalous data. So that is the data input line. Okay. Normalize the data. Now the thing is that here after this you have to hit the shift plus enter to get to the next input line, next code. So the data will be this is the data. Now we'll be normalizing the data by using the min-max scalar that we have already imported in the when we were importing the the libraries. Okay, so let's do it. Normalize the data. normalizing the data. Okay, so for that we have to use the scalar equals min max scalar. Min max scalar. Scalar equals min max scalar. Then data equals scalar dot feed underscore transform data. Since we are normalizing the data, so we have to write this thing. Now the data, we have to normalize the data equals scalar this scalar, that means this one, the min max scalar, transform scalar dot feed underscore transform data. Okay, so after this you have to hit plus enter and then it will be normalized. Okay, so the next, so till now, until now what we have learned, so first part is basically we have installed TensorFlow, the deep learning library, which is prominently used in neural network model implementation. And after that we have imported the several libraries like NumPy, TensorFlow, and other things like models input dense to make the layers when we'll be creating the model. And for normalization we have imported the min max scalar. Okay, it's a scalar actually. So after that we have generated the synthetic data, the normalized and anomalous data, and then we have normalized here. You can see this part. So now the data is normalized. You hit the shift plus enter to this, it will be normalized. Okay, well, so now after this is normalizing the data. So the data is normalized now. Now after this I'll have to define the encoder model. Now I'm entering, now we are entering the neural network model. We're basically creating, that is defining the neural network model. Okay, so we are creating. Now the next code I'll be writing in this very input line. So I am erasing this, but keep in mind though that code will be just after this code. Okay, now the model will be creating the encoder, the autoencoder rather. So for that, define the autoencoder model. Okay. Okay, so let's create the model. Let's define the model. Import that. Let's start with the input layer. So the neural network model, we know that neural networks basically comprise engaging of several layers, nodes. The input layers, those hidden layers, maybe one or single or multiple layers in between the input and output layer. Then the next addition will be output layer. Well, so this is the input layer. So first let's get to input. Okay. So this is input, this is dimension, is the data. So the input dimension is the data basically. Okay, so this is the input dimension, data, there is the data. Now the encoding dimension, so we'll put the encoding dimension as 10. So the encoding dimension will be n. So this is the input layer. So we have already put the input dimension and encoding dimension here. Okay. Now we are basically designing the input layer. Okay, so that's the idea. Define the autoencoder model. Define the autoencoder model. Input layer equals input layer equals, so input dimension encoding, input dimension encoding dimension. Input dimension encoding dimension, then input layer. That should be shape. And this, and what is the shape? So basically the shape is basically the input dimension. Okay. Okay, so this is the input layer. Now the encoder is so the encoder is basically the dense input layer. Give it dense. Since we are getting the hidden layers now, so we are basically going to use the dense. Okay. Then we'll come to decoder. Now this is encoder. Dense encoding dimension. Encoding dimension. Encoding dimension. Encoder. Dense encoding dimension. Encoder dense encoding dimension. Encoder dense encoder dense encoding dimension. Activation equal to ReLU. Okay, so this is the thing. Now you will be going to decoder. Here it will be input layer actually. It will be input layer, must be incorporated here. Decoder equals dense. So input dimension, then activation, then encoder. So input dimension, so decoder equals dense input dimension. The activation here must be sigmoid.